In this video, we're going to look at different problems in which we need to use linear functions to help us solve them. A rental company charges a flat fee of $29.99 and 79 cents per mile to rent a 10-foot moving van. Write a linear equation to approximate the cost, C of x in dollars in terms of x, the number of miles driven. Use the equation found to determine the cost of a 75-mile trip, and then interpret the ordered pair given in the context of the situation. So the first problem is to write a linear equation that's going to approximate this cost. So our cost is given in function notation, so our linear equation should also be given in function notation. C of x, so cost with respect to the number of miles driven, which is x, is 29.99 plus 0.79 times x, since it's 79 cents per mile driven. The next question asks us to use the equation that we found, so this linear function, in order to determine the cost of a 75-mile trip. So what we're looking for is C of 75. Plugging that into my equation, I get 89.24. Of course, whenever I'm solving any type of application, I want to interpret my answer. So a 75-mile trip cost $89.24. If this number wasn't already rounded to two decimal places, this is one place where it is appropriate to round. So when I'm just writing a regular old equation that is not within any sort of situation, we leave everything exact. So reduced, simplified fractions. No mixed numbers, no rounding. However, when I need to interpret a solution that does solve an application problem, I need to put the number in some sort of context here. So here we're talking about money. We know money, we always round to two decimal places, unless otherwise noted. The last part asks me to interpret the ordered pair 40, 61.59 in the context of the situation. So ordered pairs in this situation represent miles and then cost, where the x, the input is miles, the output is the cost. So a 40-mile trip costs $61.59. In our next problem, a business wishes to depreciate a building it just purchased. This is done so as not to expense the cost of an asset right away. Most businesses depreciate assets using straight-line depreciation, where the same amount is written off each year of the asset's useful life. The building was worth $147,500 in 2004 and is now worth $65,000 in 2019. We want to write the equation of this depreciation schedule and determine when the building will be completely depreciated. So again, we're asked to write an equation in function notation, so V of t is my output, t being the number of years since 1999. This is important, so make sure that you don't ignore it. So the first thing I'm going to do is I'm going to write the information that I'm given in ordered pairs. So in 2004, the building was worth $147,500. So 5 is my input because that's the number of years since 1999, and 147,500 is my output since that's the value of the building. My second ordered pair is 20, 65,000 because in 2019, the building was worth $65,000. I can now use this information that I've organized into finding the rate at which the building is depreciating. So since it's straight line depreciation, I need to find the slope. Using my slope formula, I find that the slope is negative 5,500, which means every year the building is depreciating by $5,500. So if you're asked to interpret what the slope means, remember the slope is a rate. The top is telling me the value, the bottom is telling me the years. So the change in value over the change in years would be it's decreasing. That's what the negative is telling me, $5,500 per year. Then I could choose either point in order to write my function in point slope form. So V of t is equal to negative 5,500 x minus 5 plus 147,500, or V of t equals negative 5,500 x minus 20 plus 65,000. Either one, it doesn't really matter which point that you use, you know that. I want to find how long until the building is completely depreciated. So if it's completely depreciated, the value is 0. I'm going to pick one of my equations and set it equal to 0. I distributed, combined my like terms, and solved for x. So I get about 31.8, which I'm going to approximate to be about 32 years until the building is completely depreciated.